Okay, so in this video, in the last video, I showed you how to make a probability distribution table using pivot table in Excel. So it was uh, it was using only one variable about health insurance coverage. Now let me show you how to handle two variables at a time. Like for example, I'd like to decompose the health insurance coverage by gender. So I am interested in what's the percentage of men or women who do not have insurance coverage. So to do that, what I'm going to do is I'm going to include this variable gender will be clicked. I'll click it. And then if you click it, it is added to rows here. So rows is defined by two variables, which is shown like this. But this is not what we want. We will move gender to columns. Then columns are defined by the outcome of gender, right? So rows are defined by health insurance and columns are defined by gender. So this is what we want. 2 by 2 table, and as you see, we have probabilities for each of them. That is 13.8% is the percentage of women who do not have health insurance. And say 36.72% is the probability of women who have health insurance. In this way, you can calculate probability distribution table for two variables at the same time. And automatically we have probability for female. So this probability is the probability for female, and this is the probability of male, and this is the probability of no, and this is probability of health insurance, having a health insurance. Okay, so pivot table is very useful to summarize data. Then let's come back to our slide, and this is what you see. The table is what we calculated from Excel. So we have this table. Then let me ask you this question. In this data, how many outcomes are there in the sample space? Or how many outcomes are possible? Think about that. So, as I said, you may stop the video and think about this problem. You may go back to previous slides to see what's the definition of the sample space. It's up to you. Okay, the answer to this question is 4. There are 4 possible outcomes. That is, outcomes are defined by two variables, and there are 2 answers for each of the questions, each of the variables. That is, there are 4 types of people: male with health insurance, female with health insurance, male without health insurance, female without health insurance. So the experiment is randomly choosing a person, and then what you see from a person is 4 possible different answers, right? So yes or no to one question, yes or no to the other question. So in that way, there are 4 possible outcomes. So the sample space consists of 4 possible outcomes, 4 outcomes, right? And so now it is more clear to see the probability, the event is different from an outcome. So each cell is one outcome, but event can be any combination of the outcomes. Like, for example, you may think about an event in this area, colored area. So this event is a little bit strange to say that this event includes all women and men with health insurance, right? So it does not include men without health insurance, but it includes the other three types of people. Then its probability is the sum of these three probabilities. So the probability of the colored event is the sum of the probabilities for each of the outcomes, right? That's how we calculate, how we attach probability for any combination of outcomes, right? And here, what we are going to learn from here is so this is a very simple example. This is simplest possible example for multivariable case. So it is only 2x2 case, but as you see from the real data, we have like 8 variables, and some variables can have like many possible outcomes, like education or income, for example, or like age, whatever. Then an event can be much more complicated to depict like this, and you may not be able to make a full probability distribution table when there are too many possible outcomes. In that case, we need new notation to describe those information, those events, right? So we are going to define new mathematical notation, which is based on the set theory. Mathematical set theory is the basis for this notation. So let's start like this. So let's define F stand for female and H for health insurance. So F and H are the information you have, or right? Yeah, information you are interested in, or the event you know or you are interested in. And we are going to denote the probability of those events as probability PR of F. So you can think it as a function defined for an outcome, for an event, sorry. So a probability can be defined for each event. So if you use an event as an argument, then this function gives you its probability, right? It's a function. And then what we are going to study here is, based on these two informations, you can make up different events, more complicated events like this. So this kind of event is one event that you can think of, but it is not easy to describe. But as I said, we have mathematical ways, notation, that can express any event based on these basic events. So mathematically, we need only 3 operations, only 3 notation to make up a new event. So the 3 notations are and, or, not. And, or, not are the only 3 operations or expressions that we need to express any new mathematical statement. It is a mathematical theorem from information theory. So what you need is and, or, not, right? So we are going to learn each of them. First thing is not. Not. So that is, we defined female as F. That is our basis event. And then how can we denote male? Simply, you can denote male as negation of female, the opposite of female, right? So male is the collection of all outcomes not in the basis event F. So casually speaking, we can understand it as not, but in set theory, it is called complement. So as I said, so event is a set of outcomes, and then the other side of the set is called complement set, and it is denoted as F superscript C, F complement. You may understand simply this as not included in F, or event F does not happen. So if that is, again, so if you have information about F, automatically you can define event negation of that, or event that the original event does not happen, and you can define its probability. Similarly, H defines, H is those who have healthy insurance. Then those who don't have healthy insurance can be denoted as H superscript C. Again, it is not. So then how can we define the probability? Pretty simple. What is the probability of F complement, which means male? Try this. So if you follow the definition of probability that I explained earlier, you can check the most fundamental way is to check what outcomes are included in this event. F complement includes, there are 4 types, but it includes only these 2 types, right? So these 2 colored outcomes are included in that event. Even though the notation is, maybe you may not be familiar with the notation, but the point is to tell which outcomes are included in that event. And then once you identify the outcomes included in that event, you can sum these 2 probabilities, right? So probability F complement is 49%. So this is a fundamental approach, but there is a better way, maybe more useful way to calculate the complement probability. Simply, you can use this. So suppose that you know event A. You have information about an event A, and then you can think of only 2 possible cases. One is the event A happens, or A does not happen, which is A complement happens. So A does not happen equals to A complement does not happen. A complement happens. Oh, I'm confused, but you know what I'm saying. So that is the probability that A happens plus probability A does not happen must sum to 100%, because there are only 2 cases, so their sum must be 100%. That means the complement probability can be obtained by calculating 100% minus the original probability. So this is a simple way to calculate the probability for complement, and we call this complement rule. Okay, so we are going to now, so among the 3 operations, we learned complement, not, and the other and or will be covered in the next video. I'm going to show you how we denote and or in probability setup. Okay, thank you for watching, and see you in the next video.